So we are on page 597 doing the practice test. This is number 5. A random sample of 100 voters are sampled in a small city, 59 voters in favor of candidate A, and we have a null hypothesis of 50% versus an alternative hypothesis that more than 50% like this person. So the test statistic is how we figure out that z-score, right? So this wasn't out because I used a t, and let's see. So it's the number that we're after, or the number that we got, right? So that was 59% minus what we think it is. So that's on the top. And then on the bottom is we take, remember, don't make the mistake that I made, it's the value of your parameter, the 50%. So it's going to be 0.5 times 1 minus 0.5, which is also 0.5, divided by 100. Okay, and that is choice B. Okay, so once again, here's the number that we got. That's our parameter. The parameter that we're interested in, minus 1, divided by how many we have in our sample. Done. Number 6. So they say that there's a drug that causes people to grow taller, so they're going to do a statistical analysis or a significance test. Anyway, you read this whole thing and find out that they're just interested in how do they increase the power of the test. What are the 2 ways to do that? Well, you can either increase the sample size or increase the alpha level. Those are the 2 things that we can do to help increase the power. And which one of these is saying that? Well, let's say C, it looks like using 0.05, right? Increasing the alpha level instead of 0.01 to 0.05. That's the correct answer. And next, number 7. So we are going to have a 95% confidence interval, population mean calculated, and the interval is somewhere between 1.7 and 3.5. Assume the conditions are met, blah, blah, blah. We're testing for 2, an average of 2, whatever they're talking about. And that's in that interval, isn't it? It's between 1.7 and 3.5. 2 is in there, which means we would fail to reject the null hypothesis. Let's see if that's one of our choices. Yes, it's there. Letter E, we would fail to reject the null hypothesis at the 0.05 level. There we go. Okay, next. Number 8, we have a null hypothesis of 0.4 against, not equal to 0.4. Okay, so this is a 2-tailed test. Sample size 100. The test statistic comes out to 1.28. What is the p-value? So remember that 1.28 tells us we are, if this is 0, 1.28 standard deviations above the middle. Okay. 2.8, like that. Okay, now what we want to do is figure out what is that area. So I put in normal CDF, negative 1,000 to 1.28, and I got a value of 0.899, which I subtracted from 1. Okay, 1 minus that, and that's going to give me approximately what is going on with this thing? 0.10. But don't forget, we need to multiply it by 2 because it is a 2-tailed test. So it should be approximately 20. There. Got it. So, where is it? D is the answer. Number 9. So we're actually going to do a test on this one. So a simple random sample of 100 postal workers. 7 years was the average for them, with a 2 years standard deviation. Now, 20 years ago, it was 7.5. So we want to determine if things have changed dramatically. So our null hypothesis is 7.5 versus a two-tailed test of not 7.5, 5% significance. Okay, so let's see, what do we got to do? Oh, t is equal to, so the number that we got was 7 versus what we're going to test it against, which was 7.5. For some reason, I can't make a point on this stupid thing. Let me try. There it is. Okay. And we're going to divide it by our standard deviation, which is 2, divided by the square root of 100. Okay, because that's our new standard deviation. So I'm going to do that math and see what the answer is. And the answer is negative 2.5. Negative 2.5. 5. And, come on, give me a point. There it is. Okay. So I'm going to do this. I am going to do TCDF with a degree of freedom of 99 to see what my p-value is. So I get, now I don't subtract from 1 since it's negative. We're doing this kind of action. We're at negative 2.5. We want to figure out what that area is. TCDF. Turns out that it's 0.007, but we got to multiply it by 2, so it's going to be 0.014. Well, still at the 5% significance level, we are going to reject the null hypothesis, since that p-value is so low, in favor of the alternative hypothesis and say things have changed. And that would be letter A. Bada bing. Okay, let's try the next one. Okay, so number 10. Have you ever noticed this, that the commercials are way louder? So what they're going to do is they're going to look at, they're going to measure, they actually measure the loudness, the maximum loudness for the first 30 seconds, right? And then compare that to the loudness of the regular programming after the commercial. So before and after, they measure those two loudness levels, and they're probably going to subtract them and see what the difference is. Now, because they're taking a measurement, right, it's not just a yes or no answer. Are they loud or are they not loud? So that rules out any of these proportional things, right? A proportion is like a z-test, z-interval. That's kind of a yes or no answer. And so what we're going to do is, they don't ask us what the actual sound level is. So that would be an interval. That would give us a guess of what it would be between. So it's going to be a paired test. They measure before and they measure after, and then they see the loudness level. So that would be letter C.